In this video, we're going to apply the Pythagorean theorem. Before we do, let's look back at our diagram where we introduced the Pythagorean theorem to come up with our formula, which is in your media lesson packet, that was based on this diagram. Okay, so this was for a specific diagram where we had a triangle. This was length 3. This is length 4. And one of the things we found out in this problem was we wanted to find this length, and we found that the length was 5. Now remember how we found this? We said, okay, 3 squared plus 4 squared equals this question mark squared. And that was based on the fact that we said that the pink rectangles combined equaled the blue, 4 blue triangles. So this is 3 squared, this orange is 4 squared, and that must equal the yellow square. Okay, so 3 squared plus 4 squared was 25. Okay, so that's 9 plus 16. And then we said to find the length of the side of the square, we would find what number times itself equals 25. And we said that 5 squared is 25. So the side length of the square was 5. Now notice, if we look at this as question mark, now that we've looked at square roots, we basically found the square root of 3 squared plus 4 squared. We did this in steps, where first we took 3 squared and 4 squared, we found 9 and 16, we add them together, and then in the end we took the square root. And this is the basic result of the Pythagorean theorem. But now let's write it specifically or generally in terms of any legs or hypotenuse. Okay. So this is a right triangle. You must have a right triangle. This shows that this is a right angle. That means these two sides are perpendicular. Okay. C is special because it is the hypotenuse of the triangle. And that is the side that is across from the right angle. We call A and B legs, and it doesn't really matter which one you call A or B. So here, lining these up, we call A 4 and B 3, but notice in the formula, if you switch them around, it's just addition, so it actually doesn't matter. So the Pythagorean theorem says that A squared plus B squared equals C squared. This statement is always true. And we're going to apply this theorem in the next few problems and learn how to solve for the hypotenuse in general, like we did here, or for a leg. Okay, and again, these results are in your packet. So let's look at the first problem. So we're asked to find the unknown side of the triangle. Okay, notice we're given that it's a right triangle because we have this symbol here. Okay, and the side that's missing is the hypotenuse, the side opposite the right angle. So we are going to use this formula that says the hypotenuse is equal to the sum of the squares of the two legs, and then you take the square root. Okay, so it doesn't matter which you call A or B. Okay, so we want to find C. So 12 squared plus 7 squared. Okay. Now I'm going to put this into the calculator, and your calculator will do this in one nice step. This one that came with my computer isn't as fancy, but basically I want to take 12 squared. I want to add 7 squared. And then this is my result. Never ever round until the very end. So if this was a decimal that went on forever, don't round it. You're going to take the square root directly in the calculator of whatever your result from this is. And now I'm going to hit the square root button. So this is 13.89, rounded to 2 decimal places. Okay. So a few notes on your calculator. Okay, on this one we saw that I hit 9 and then the square root button, it gives me the square root. On yours, you hit the square root button, it actually shows you the square root symbol, and you put in the value. Okay, if your calculator does not give you a decimal value, if it still has a square root in it, if you're using the multi-view calculator, then click on the button right above the enter button that has 2 arrows on it, and that will give you a decimal approximation. Okay, so this is what we sum up this problem. This is what we use when we're solving for the hypotenuse. Okay, in the next problem, okay, we're given a right triangle, but notice we know the hypotenuse. We know the value or the length of the side across from the right angle. We want to find the length of a leg. Well, we know a squared plus b squared equals c squared, okay? And we can do a little algebra to find what one of the legs equals, okay? You don't need to do this algebra, but it's good to follow along. So a squared would equal c squared minus b squared, okay? So we'd find the difference between the hypotenuse squared and the leg squared, and then we take the square root. Okay? So you'll be provided these formulas on exams, but you should be familiar with which one to use and how to use it. Okay, so again, we could have called this AB and this BA. Doesn't matter which leg you're missing or what it's labeled as. If you're looking for a leg, you use this formula. So A equals the square root of 17.3 squared minus 3.8 squared. Now I'm going to put this in the calculator. So first I'm going to put the part under the radical, 17.3 squared minus 3.8 squared. I'm going to hit enter, and then I hit the square root button. And we get that this is approximately, to 2 decimal places, 16.88. So A is approximately 16.88, and that was meters. Now we're going to look at some application problems. Okay, so this one is a basketball application. In NBA basketball, the width of the free throw line is 12 feet. So I had to look this up. This is the free throw line here. That's where if somebody gets a free throw for whatever reasons, you get free throws. Sorry. You would throw the ball from here to the basket. So this is 12 feet, and it says a player stands at one exact corner of the free throw line. So player 1 is here and wants to throw a pass to his open teammate across the lane and close to the basket. So he wants to throw the ball to this teammate. Okay, so I assume he has the ball. Now his other teammate, so he has a teammate here. That teammate is closer, and it says he's heavily guarded, so that means he might want to throw it to this teammate because he's closer or she's closer, but there's a lot of people blocking this person. But we know that this distance is 16 feet. And we're asked, how far is his pass to his open teammate? So that's person 2. So we want to find this length. Now notice a few things, okay? If this is 12 feet, since these are straight down, this is also 12 feet. This is a rectangle, this big diagram, okay? And then if we use this dashed line, we can think of this as a right triangle. So there's a lot of right triangle applications where you use the Pythagorean theorem. It's when you're trying to find a missing side, and you need to look for right angles to make sure that you can use the Pythagorean theorem because you need a right triangle. So now notice we want to find this length. We know this length, and we're missing the hypotenuse because it's across from the right angle, the value we're missing. So we're going to use C equals the square root of a squared plus b squared. Okay, these are my two lengths, 12 squared plus 16 squared. Let's put those in the calculator. So 12 squared plus 16 squared is 400. And now I'm going to take the square root, and the square root of 400 is 20. So square root of 400, which equals 20. So that means this distance that he'd throw the pass is 20 feet. And we'll write that as a sentence. The distance is 20 feet. Okay. So this was an application where we were given two legs of a right triangle and we wanted to find the hypotenuse. Let's look at one more. Okay. So Sarah is flying her kite and it gets stuck in a tree. She knows the string on her kite is 17 feet long and she is 6 feet from the tree. And we're asked how long of a ladder in feet will she need to get her kite out of the tree, and we're going to round to the nearest hundredth. Okay. So here's a general diagram. This could be a little bit misleading, so let's make a geometric model. Okay. So she knows the string on her kite is 17 feet. So lining up here, this is where she's standing. So this distance from here to here would be the kite string. Okay. And I wanted to redraw this because here it looks like she's holding it high in the air, so this would be a longer distance. But we're basing this on the distance from the ground to where the kite is stuck in the tree. This string length is 17 feet. Okay. And it says she is 6 feet from the tree. So this is the tree. I'll try to draw one. Not the worst tree I ever drew, but certainly not the best. So the distance between her and the tree is 6 feet. Okay. And we want to find how tall of a ladder she needs. So basically the height of this tree, okay, to get right up here to get the ladder out, or to get the kite out, excuse me. So notice we have the hypotenuse here, and the height of the tree, the ladder we need, is a leg. So we want to use A equals the square root of c squared minus b squared. Okay. So this height, which I'm calling A, we want the hypotenuse squared, which is 17 squared, minus the known leg, 16 feet squared. Now I'm going to put that in the calculator. 17 squared minus 6 squared. Oh, I think I hit something wrong. 17 squared minus 6 squared gives us 253. And now we will take the square root, and we get approximately 15.91 rounded to the nearest hundredth. So A is approximately 15.91. Okay. So that means she needs a ladder that's at least 15.91 feet to get the kite out of the tree. So she needs a ladder at least 15.91 feet. Okay. So again, in this application, okay, in the structure of the problem, when you make a geometric model, you see that there's a right triangle. Okay, the right angle here was formed between the tree and the ground. Okay, you know two of the lengths and you need to find a third one, and this is when you can use the Pythagorean theorem.